Hello, everyone. Thank you for joining this session. First of all, let me acknowledge the support from the Telia carrier for providing this platform. It is a partnership between the Internet Society's MANRS initiative alongside the Telia carrier. The reason for that is the Telia carrier has been a strong supporter of the routing security, and they have implemented some very strong security measures to make sure the global routing table is secure for everyone. And that's why we are partnering with them to be on this stage. Myself is Aftab Siddiqui. I'm based in Sydney, Australia, and I am part of the initiative called MANRS, Mutually Agreed Norm for Routing Security. And today we will be talking about a little bit more about routing security. You heard a few things from my colleague and friend, Kevin Maynell, a week ago. So we will be digging from there. But before we go into the deep dive, I would say we will discuss some basics first, just to make sure that we are all on the same page. And if you have any questions or concern or like to discuss something related to the topic, please make sure that you raise your question or concern in the chat or in the question side, I guess. So let's start. First of all, so what are we talking about? The agenda for today is going to be, it is small, but there are so many details in it, so you have to buckle up and follow me. Right, so this is the agenda, a quick overview of the BGP. I'm not going to explain what BGP is. If you are joining this session, I'm pretty sure you are aware of that, but we will just go through it a little bit. BGP traffic engineering tools, or I would say the attributes we use, like local preference, MAD, AS path, prepend, communities, etc. BGP operational securities, networking risk filtering, and overview of the internet routing registry. And of course, a little bit of introduction for the RPSL and introduction of RPKI, which is ROA and ROA validation. And then we will give you a hint of the lab, which you can access from your own home or office where you want to access and practice whatever we are going to discuss here. Right. I mean, this is a very basic diagram that how internet works, how normal routing works. You access something on your laptop, you write google.com, and then it magically appears on your laptop or PC screen. There is a madness behind that magic, and that madness we will be discussing later today. Routing protocol has a very basic function. There is you use that to make sure that you are able to reach your destination and then come back. There are certain routing protocols available for us, whether you are using it within your infrastructure or to communicate outside the infrastructure. There are two distinct types of protocols, which is called the IGP, which is the interior gateway protocol, and the exterior gateway protocol. In the exterior side, we have only BGP at the moment. And in the interior gateway protocol, you must have heard about a couple of them, RIP-NG, EIGRP, OSPF, and the ISIS. But we will be talking about BGP today extensively. So to understand BGP, you need to understand how do you differentiate the network in a BGP. And that differentiation is called the autonomous system number. That is the group of network under a single administrative control, right? It can be one ISP or one enterprise. Single ISP can have multiple ASN as well if they want to divide their network into multiple administrative boundaries, or multiple ISPs. Once they merge, they can combine into one AS number as well. And this is how the information is shared between multiple ISPs. BGP is based on the rumors. Whatever you know, you share it with the other ISPs. The other ISPs, they know, they share it with you. And that's how you learn about the whole internet routing table. Again, there are certain terms we should be very clear about once we talk about the BGP. Number one is called peering. Exchange routing information traffic directly with the peer. It usually is free. I mean, of course, you might have to pay the cost of the port where you're physically connected, or maybe the physical cable you are laying between the two networks. Otherwise, usually it is free. Transit, this is what you buy. It comes with a cost. Then you have to connect to the global routing table, and that's how you buy the transit. Default is where you send traffic when there is no explicit match to the routing table. It is usually for small ISPs, or those ISPs who cannot install the full routing table, or if they have only one transit provider, they sometimes prefer to have a default route. DFZ, the default free zone, where you know the whole routing table, where you're installing the whole routing table, and you are not relying on any other ISPs for the default route. I mean, as the name suggests, it is default free zone. There is no default route in the routing table. This is the transit. Everybody buys from someone. I mean, from an upstream provider. It would be Telia carrier in many places. In case of in Australia and Sydney, we have Telstra, we have Hurricane Electric, we have other players. You pay a fee, and then you can access to the internet routing table. But if you want to connect with another ISP in your own country or in your own state, or closer to you don't have to buy the transit. You don't have to go through this expensive link. You can directly put a cable between two ISPs, right? And this is where the peering comes in. I mean, as I said, you might have to pay a small amount for this cable or the physical port you are connected to, or maybe internet exchange point is there in the middle where you are paying a membership fee or something. But this is much more, this one is much more expensive than this peering. Right, again, BGP. BGP is termed as the protocol of the internet, because it is the only protocol we are using at the moment to connect to the internet for sharing routing information. It's a path vector protocol. Defines the route as a pairing between destination and the attributes of the path to that destination. There are multiple attributes. We will be discussing those attributes in a short time. So just for example, this is a BGP route. This is called a prefix, so 1.0.166.0/24, and this is the next hop to reach that one, and this is the AS path. So it is originated from, so it's right to left, so originated from 239.669.8304 and 7474. So this is how this is the whole route. So once you go into traffic filtering and traffic engineering, you need to understand one very basic principle. Routing information and the packet flow is always in the opposite direction, right? When you announce something, then people come to you. When you say, hey, this is Aftab, I'm here, then people will listen to you, and then they will look towards you, or they'll come to you. Same is the case with the routing information, right? You can see when the announcement goes, the packet flows in the opposite direction. Same is the case for the other way around. Filtering outgoing routing information inhibits traffic flow inbound. If you are putting a filter for your outgoing routing information, it means you are restricting who can come in and who cannot in terms of traffic flow, not the routing flow. And when you are restricting the incoming routing flow, if you are putting the filters on what can come in, it means you are putting a restriction on the traffic flow for going outside. So, I mean, it sounds complicated, but it's once you understand that, it's easy for you to implement how the prefix filtering, and other filtering words. Certain general information. Learns multiple path via internal and external BGP speakers. Pick the best path and install it in the routing table, which is called RIB, Routing Information Base. Best path is then sent to the external BGP neighbors, called eBGP. Policies are applied by influencing the best path selection. If you know the BGP, this is just a refresher for you, saying, okay, I know everything, let's move on. Now, constructing the forwarding table. BGP in process and BGP out process. Again, this is what I explained in the previous slide. You need to understand the routing flow versus the traffic flow. Best path and the RIB are installed in the forwarding table, which is, so the RIB and the FIB. Routing table has everything, FIB has the best path in it only. And now it comes to the traffic engineering, where you say, okay, fine, I understand, I configure the BGP peering with someone, and I'm learning everything, I'm announcing everything. Everything is working, then why do I have to do traffic engineering? There are very genuine reasons for doing that, and some of them are, okay, if you are connected to one service provider, if you are a small enterprise and you're connected to one service provider, then it doesn't make much sense to do traffic engineering, because of course that's the only link you have. But if you have multiple links, of course, if you are an enterprise or even a service provider, you have to make sure that you are not relying on only one outgoing path. You have multiple paths. And if you are connected to an internet exchange point, it means you have another path where you'll be sharing local traffic or the regional traffic as well with different peers. So you have multiple peers now. And to make sure that you are announcing and accepting the right routing information, you need to understand the traffic engineering rules and how you can manipulate few things to achieve your target. Of course, there are certain caveats once you start doing the traffic engineering and tweaking the attributes. It's a very simple protocol, and this is the reason why it's been there for more than 30 years. And of course, many changes have been added to the protocol, but the architecture remains the same, what it was like almost 30 years ago. It's simple, but that's why it imposes a lot of limitations, and we'll be discussing those limitations in a short while. And of course, it's you'll be peering with somebody else, right? So one network connected to another network, you have only control of your network. You don't have the control of the other side of the network, right? So whatever influence you want, you can do it easily on your side. But if you want to influence somebody else, there are consequences. Sometimes the other party can do other different things to bypass those rules for you. So you can do only a few things to make sure that to achieve those targets. Why you have to do the traffic engineering, as I said, you have to manage your capacity. You have, for example, 3 or 4 upstream providers, and you want to make sure that you are balancing the traffic on all of them. To some extent, you can do it, but of course, you can't do load balancing. You can do the manage. You can manage the backup links. As like again, if you have 1 or 2 service upstream, and you have a backup just in case if everything goes down, you can take that one. So you can also have this certain attributes in the BGP which you can use to make sure that you are using the backup link as well. So what are the options you have? You have the AS path prepend. You can prefer, so BGP prefers the shortest AS path. And if you want to change the behavior for others, what you can do is you can prepend, you can add multiple AS into your announcement from one link and no prepend on the other link. So it will make it will not guarantee, but it will allow you to make certain. You can try to make that preference for the world that where you have done the prepend, people not take that path and take the other one without prepend. Local preference, it's a non-transitive and optional attribute. I mean, every attribute in BGP has either it is optional or mandatory, transitive or non-transitive. Transitive means it can propagate from your network to another. Non-transitive, it remains in your network. So local preference, or local pref in short, is it's non-transitive, so it remains in your network. It determines the best path for outbound traffic. You can, if you have two link and you want to select one link on whatever reason, it could be commercial reason, or it could be you have a better understanding with that network, or you're learning more routes from them and you want to prefer them. So what you can do, you can increase the local preference. Highest local preference always wins. And then there's another option called MED, multi-exit discriminator. It's again non-transitive and optional attribute, determines the best path for inbound traffic. Path with lowest MED wins. Two more attributes. Another one is called origin. It's there. It's nobody's. I haven't used it for many years, but people just. What you can do is just so you only have two options, IGP or incomplete. So you can specify IGP for all the routes, so it doesn't make much difference. But the communities is the most important one these days. People rely on it quite extensively because a lot of service providers and for example, Telia also offers a long list of communities that you can use. Then it will help you to manage your traffic, inbound and outbound traffic as well. Now, so because the session is about the routing security, right? So before we go into the details, we need to understand what is routing security. Again, it's just a recall. There are more than 71,000 networks across the internet. And how do we know that? Because there are more than 71,000 ASN in the global routing table. They all are using BGP. And of course, the routing table is routers are building the routing table where they make the decision on the basis of what route they see in the routing table. And now the problem, which I explained a moment ago, is BGP is more than 30 years old. And when it was designed, the idea was, well, everybody trusts everybody. 30 years ago, there were very, very small, small number of networks, handful people trusting each other. It was research institutes versus universities and some defense institutes. They were all connected to each other. Nothing fancy. Everybody was able to recognize everyone. Fast forward, now you have 71,000 plus something network in the routing table. It's hard to build that trust at this day and age. The chain of trust spans continent. I mean, I'm sitting in Australia, Sydney, and if I'll be connected to people who are sitting in different continents. So the trust is very hard to build in these circumstances. Then there's a lack of reliable data on which we can base those decisions, where we can make a trustable relationship. We'll discuss about the reliable source of data as well, moving on. So yes, these are the problems which BGP poses, but this is the protocol which we are using for that many years, and it's working for us, and it's very scalable. So we have to make sure that we use certain measures to protect the routing protocol rather than changing the routing protocol. Well, because of these because of the trust-based model of BGP, you see these headlines quite often, and this is from last year, right? So there was a testing mistake triggered by Telstra's route hijack. It was just a mistake. It happened from, last year in September, and then it created a because everybody's connected to everybody. It's an internet, right? And that's why it caused it created a massive hijack for a lot of service providers. Email provider, for example, Proton Mail was affected, so as the DNS service provider as well. And then middle of the year, last year again, a Russian telco hijacks internet traffic. And then Google, AWS, Cloudflare, and many other networks were affected as well. These could be just genuine mistakes, right? Or could be an attempt to deliberately disrupt the services. You never know. Unless you make sure that everybody's implementing these measures, you can put some barriers in place to avoid these problems. And even somebody try to do that, or somebody create a mistake, you can stop the propagation of these mistakes. This is just the data from last 2 years, 2020 and 2019. You can see there were incidents every day, whether it was a hijack or a leak. We'll discuss what is a hijack and what is a leak. And it was happening on every day. I mean, just because you were not impacted, or just because it was not a big news on CNN or BBC, doesn't mean that it didn't happen. If you go to the bgpstream.com, you will be surprised at how many incidents happens on daily basis. Most of the incidents are very short-lived. They don't, and that's why they don't impact you much. But it means someone was not doing the right thing, and that's why it happened. Or someone was not, or their neighbors or their peers were not implementing the right measures, and that's why it was leaked. So there are three major incident types which we see in the wild. Two are related to the BGP, the routing protocol, and the third one is not related to the BGP, but it's still very prominent, and it can be solved easily. So the two most important ones are called the prefix or the route hijack, or the prefix or route leak. Right? There's a small difference between the two. We'll discuss it right now. And then the third one is called IP address spoofing. Right? It's been there. If you have heard about a term called BCP38, you'll be surprised that it's been that BCP is there for more than 20 years now, and still we are talking about it. This is one of the cause for the DDoS attacks, whether it is NTP reflection or DNS reflection attacks. If the network providers implement anti-spoofing, you can get rid of these attacks as well. So let's again talk about these connectivity types, right? It's in a nutshell what you are. Either you are a stub network. I mean, you're not providing any service to your downstream customer. You are the only one. It's your only enterprise. For you to make a problem in the global routing table is very small, right? And you'll be surprised to know that out of those 71,000 networks, 80% of the networks are stub networks. Means they don't have any downstream customer. They are their network is connected to the routing table, and that's it. They are the only ASN. There's no one below that. But you can be connected to multiple service providers. So you are multi-homed. You could be connected to an IXP. So that means you are multi-home, and that gives you an equal opportunity to hijack or leak predominantly a prefix or a route. Or you are a transit provider. I mean, it means you have downstream customers, or you are an IXP as well. So these are multiple connectivity types. If you are a network provider or network operators, definitely you fall under one of these categories. Right. So this is just an explanation of what are these. So now let's talk about the prefix and route hijack. So what is a route hijack? It's you hear this term. It could be people use these terms quite interchangeably, right? Prefix hijack or route hijack or a BGP hijack. They all gives you the same definition, right? You have started announcing a route which doesn't belong to you. Simple as that. So, or someone is announcing a route they are not authorized to. So in this example, there is two customers of this service provider, and there is ASA. So they were announcing their own prefixes, and all of a sudden, so they were announcing the prefixes to reach, and ASA wants to reach customer 1 because they were announcing their prefixes. All of a sudden, ASX announcing the same prefix from here, and as I said, the shortest AS path along with the prefix length will always win. So that's why they were able to hijack the traffic from here to ASX. So this is very common in terms of the route hijacks. And a very recent example I can give you from here is this one. This expected prefix was 2A06CF00:/29, and the expected ASN was supposed to be from 62365 from DESAnet. But what happened on 28th of February, 1513 UTC, that they detected the same /29, but the origin AS was not this one. It was 269684, which is LAN Fibra Telecom in Brazil. I mean, it's a very long distance from Germany to end up in Brazil. So you can see there. This is how common they are. If you go to the, as I said, if you go to the BGP stream, you'll find a long list of hijacks. But most of them are very short-lived, and these were very short-lived as well. Definitely somebody made a mistake and end up announcing those prefixes as their own. But you can imagine everybody, if somebody in Brazil wants to access this prefix or a website hosted on this prefix, then they will not gonna reach them at all. They will all be heading towards the LAN Fibra because they are announcing it as well from their ASA. Now, route leak is a bit complicated one, right? So what happens is you are connected to one. So these are two customer of this ISP. Everything is working fine, but this customer decided to have another IXP as a backup. And they, of course, they are also speaking, they are also connected via BGP. All of a sudden, what they did, they started leaking their routes from here to the other customers. And you end up going from so the direct path for you was to go from here to here and to your destination, Google. But because of this leak, all of a sudden, what is happening now that you are coming here and then going from another customer side and then from third ISP and then to reach Google. You are still reaching your destination, but you are going through a path which can be suboptimal. Maybe this network is doing an eavesdrop. They are sniffing your traffic. They are looking at what is going on, or this link is so small that your traffic is black holing or just dropping because there's no capacity available. So there are multiple issues with the BGP leak. You never know what is happening with your traffic, whether it is reaching the destination, but you're still getting the destination route, and it is coming from the same origin. So origin hasn't changed, but the path has changed so drastically that it is going through a very different path. And on that path, anything can happen. So there's a long list of what is considered as the BGP leak. There is an RFC if you want to read. You can go through that. There are 5 different scenarios where a BGP route and hijack and leak is defined on the basis of past incidents. Again, this is a example of BGP leak, but it's from the last year. So it was supposed to be announced from AS 134190, but it ended up taking a route which was suboptimal. Now, IP address spoofing. As I said, it has nothing to do with BGP. It can be implemented even if you're not doing any, if you're not peering with anyone, and it can be done as closest to the edge, downstream edge as possible. So what it says in a simple term is when a packet leaves your network, every packet has 2 IP addresses. One is source, another one is destination, right? Source IP address is always the one which generated that packet, right? And destination is where that packet is going. Routing decisions are based on destination only, unless you have a policy to look at the source as well. But mostly the routing decisions are based on the destination. That's the normal behavior. It means that you're not looking at the source. Whatever is in the destination, you just make your decision on the basis of that destination. For example, if you're not looking at the source, and if I put a bogus source in that field, you will make the decision on the basis of destination. Packet will leave your network, and when it will reach the destination, it will check. The destination will check from where it came, and it will see the source address. And of course, it's a bogus address. It is not going to come back to me then. It will go to that address. And if I start sending thousands and thousands of packets with that bogus address, whoever that address has will be inundated with that many responses, even though they never made any request at first place. So this is a address spoofing attack. And if you can amplify it with, let's say, hundreds and thousands of requests, of course, you can create a DDoS attack for that destination. And if it is coming from multiple sources, of course. So the way you can stop it is that there are multiple anti-spoofing techniques. We will discuss it shortly. So this is the impersonation attack I was talking about. You can put a fake source address, and of course, it will inundate the victim. And if you can do the reflection with multiple source, then of course that will create a DDoS. Some of the famous DDoS attacks you have heard about in the past were because of the DNS amplification or the NTP amplification. This is a website called, there's a project called Spoofer Project hosted by Qaeda. They do measurements on the basis of what people are running from their network, and they check if your network is actually doing source address validation, right? So you can go to spoofer.qaeda.org and then download a small software and then run that software. When you run this software, it will give you a report and will tell you if the ISP you are connected to is doing any source address validation or not. And they generate multiple fake source, multiple packets and put fake source addresses on it, and see if it reaches the destination or not. If it reaches with the fake source, then of course it means that your ISP is not doing source address validation. So you can see a lot of yellow and red in this map. The reason there, so let's, for example, Australia is light green, right? It's not dark green, right? So it means that all the ISPs are doing source address validation in the country. Or New Zealand is dark green. It means everybody is doing source address validation in the country. Well, no. It means the ISPs they have tested are actually doing the source level validation. Maybe there are certain ISPs who are not doing it, but at least a good chunk of ISPs are doing it. So if you are from an XYZ country, you can go and check your country listing if it is doing the right thing. And once you click that, you can list down the ISPs who have already been tested. If your ISP is not part of that list, we recommend you to do that test and figure out if it is happening or not. Again, this is the list. Now, let's talk about how to fix these problems. So we learned about the problem. So there's a route hijack and the route leak and the IP spoofing. So how to fix this problem? I mean, I'm a big fan of RFCs. If you don't know about the RFCs are, I mean, by definition, it's a request for comments, but these are the documents. Some of them are standards. Some of them are just for the information. So and some of them are BCPs, which is called the best common procedure or best common operating procedure, BCOP or BCP. So this one, RFC 7454, is the most important one if you are in the space of BGP operations. If you configure BGP peering and you do anything related to router BGP, your AS number, I would recommend you to read this one, 7454. It's few years old. It's not recent, but it is still very relevant. It's BCP 194, and its name suggests BGP operational security. Right. So why filtering? Number one, of course, this is your first line of defense. You can decide, because it is your network, and in the network community, it's a very famous rule. It's my network, my rules, right? So you can decide what can come inside your network, and you can decide what goes outside your network, what announcements are going outside your network. So you are the gatekeeper of your network. So you have to make sure that there is a gate. So if you configure everything by default, at least in the newer Cisco iOS XR version and the Juniper OS, you do have to create a filter to make sure that your announcements are going out and what is coming in. In the past, in the iOS world only, by default, everything was allowed. So that was a problem. But of course, vendors do realize this. There was a problem. They're also trying to fix it. So there is another man-in-the-middle attack possibility in the BGP. It is not very common, but I would recommend you to read about the TCP/AO. One of our friend, Melchior Elmans, he did the presentation recently about the TCP authentication option, which can allow, which can help you make sure that there is no attack on the BGP session itself, right? Then the most important part is the prefix filtering, right? So you have to make sure, again, if we go back to the start of the presentation, we had a couple of discussions about traffic flow versus the routing information. So what you announce to the internet and what you accept from the internet in terms of the routing information is very crucial. You have to make sure that you are not announcing anything, you're not announcing any garbage to the internet or the global routing table, and you are not accepting any garbage as well. So there are certain agreed lists. Many network operators have decided that these are absolutely no, and they should never be on the routing table. Unfortunately, sometimes we see that, and the reason is because not many people implement it. So what are those lists? Prefix filtering, IANA allocated prefix filters, RIR allocated prefix filters created from the IRR, Internet Routing Registries. Then SIDR and the prefix that are too specific, filtering prefixes belonging to local AS and downstream customers, IXP LAN prefixes. So let me go through them one by one. So IANA, which is the body which allocates the IP addresses to the regional interregistries, they have reserved certain, they have, of course, allocated all the IPv4 addresses, but they still have a long list of IPv6 addresses which they haven't allocated to RIRs. If they haven't allocated to anyone, then of course they should never be on the routing table. So make sure that you filter them out. RIR allocated prefix filters. RIRs have allocated in some regions. RIRs have allocated all the IPv4 addresses, but some regions they still have handful of IPv4 addresses and a lot of IPv6 addresses available. So make sure that those addresses are not in the routing table as well, because they are unallocated. Prefix filters created from IRR. So there are certain tools which you can use and make sure that you only allow prefixes on the basis of route object entries. We'll talk about it in a short while. Then prefix that are too specific, and for our IPv4 world, anything other than /24, you should not be accepting it. And for a for IPv6, it should be /48. Some people do allow /56, but I don't think so. It's a good idea, and that's why you see a lot of /56 in the routing table as well. If you have local customers, if you have downstream customers, you should not be accepting their prefixes coming in from the internet, right? So they are your customers. So if you are receiving those prefixes from the internet, there's something wrong, right? So you should never be accepting the prefix from the internet for your downstream customer. And if you're connected to the IXP, then IXP LAN prefixes should never be part of the global routing table. So most of these prefixes are hard-coded, right? So some of these prefix filters are hard-coded, but some of them are very dynamic, right? And that gives us two options. Either you can do loose or you can do strict. Loose is you can only go ahead with the those prefix filters which are very static. They don't change very often. But the strict ones are, you have to make sure that you are applying those filters and reviewing them on, I would say, weekly basis. Inbound, again, what you do is prefix that are not globally routable, prefix not allocated by IANA, IPv6 only, of course, routes that are too specific, prefix belonging to the local AS, IXP LAN, and default routes. That's for the inbound. And if you want to go ahead with the strict, you can use the IRR entries and create your prefix filters dynamically. Same is the case with the outbound. When you are talking about the outbound prefixes, you're making sure that what you are announcing to the world is filtered. You're not announcing any garbage from either from your own customers or from your own self. Max prefix filtering. Make sure that you put a limit that how many prefix you can accept. There are certain reasons for that. Number one, it could be the platform you have, the router you have has a limitation, right? It could be, right now we are almost hitting a 1 million v4, v6 routes. So if your platform doesn't support more than that, make sure that you do have a prefix maximum prefix filter there to avoid your router. Your router may melt because of that. So you should put a limit. AS path filtering. There's a problem which we saw in the wild, I think, a few years ago, when someone started announcing a big AS path length, and it ended up causing a lot of, so some of the Cisco routers started rebooting because of the length issue. But there's another problem which is you can also hijack an AS number. without hijacking the prefixes. And we see that a lot of time because of wrong configuration. And the reason for that is a lot of networks still filter the prefixes, but they do not filter the AS number. It means that anyone can hijack the prefix if they want to. I mean, they're not going to achieve a lot, but if they hijack the AS plus the prefix, they will be able to bypass a lot of filters. For example, they can bypass the RPKI or the row validation filters, and they can bypass other filters if they are based on the IRR database. So make sure that you do filter on AS path length plus AS as well for your downstream customers as well. Now the anti-spoofing, BCP38, the RFC suggests 2827. It's a very old one, but it gives you the option to filter on your network. You can filter out the invalid source addresses, filter close to the packet origin, as I said, towards the customer edge, filter precisely as possible. So there are multiple options. Either you can do an ACL, which is a very old method, or you can do URPF, which is automated, right? So you just implement the URPF, which is unicast reverse path forwarding, and the router will do the magic for you. There are multiple options in what type of URPF you want to do, whether you can do loose, strict, feasible path, and VRF. I mean, depending upon the routing router vendor, there are multiple options available. So if you want to do the URPF, reverse path forwarding, it just makes sure that you are not accepting a source address on the basis of you're not accepting a bogus source address. You are also checking the source address field as well. But there are multiple options. You can decide on the basis of which options works well for you with the specific vendor. Right. These are the command lines. You can have a look how simple it is. You can just verify. And ACL can also be used towards a provided server when URF cannot be used because of platform limitation, as I said. And another point is coordination. When you receive a resource from an RIR, which is Region Internet Registry, for Europe it is RIPE NCC, for Asia Pacific it is APNIC, for Africa it's AFRINIC, and Latin America LACNIC, and North America ARIN. They give you an option. They give you the opportunity to make sure that you maintain your maintain the data in the Internet Routing Registry. So it is your responsibility to make sure that the data is correct and you update it whenever there is a change. So this is just an example I've taken from a service provider in APNIC region. So you can see there's an abuse contact called IRT object, which is the incident response team, which is unique in the APNIC region. Everybody else, everywhere else it is called abuse C. So it gives you the opportunity to contact that service provider in case there is a problem from that side. So make sure that you do have this information available. I think almost every RIR validate this information every quarter or maybe 6 months. So there is a possibility that information is valid, but sometimes it is not valid at all. Then there is another option called peering DB. Well, there's a typo. It's a peering DB. If you are a network operator and you have an ASN, make sure that you update your peering DB account and provide the relevant information there. So it can help other network operators to put filters in place. It's easy. You just go there, and it's free. You can just go there and create your own account and provide information accordingly. And last and the most important part is the global validation, right? As we discussed initially, that you have only control of your own network. You don't control the other side of the network. And the other side for the internet is like 71,000 networks. So you don't control that. So how do you make those decisions that what is coming towards you? And if you're a big service provider and you have like 5,000 customers and all speaking BGP, then how do you manage those filters? There should be an automated way to make sure that everything is correct and what you are accepting. So there are two options of global validation. One is relying on IRR data, which is Internet Routing Registry. Every RIR provides the IRR data base, and there are multiple service providers who run their own IRR database as well. So you can rely either on the IRR database, or there is another option called RPKI, which is the Source Public Key Infrastructure. So the most important part for, if you, there are two ways, as I explained, either you can do IRR or RPKI. So this is the example of a normal whois. If I do a whois of 1.1.1.0/24, this is the information I get. It says this is the route, this should be the origin, and the description is just a text. It doesn't make any difference to the router, but these are the two most important things. Route, what is the route, and what should be the origin. And this information is coming from APNIC, which is, of course, the RIR or the delegate. This prefix, this subnet came from APNIC and allocated to Cloudflare. But if I go to whois from radb.net, then you get two information. One is from the source APNIC, and another one is coming in from the RADB itself. And of course, the information is correct in both sides, just the format is different. A route is this, and the origin is AS135. Description is different for both of them. And I said description is just a tag. It doesn't make any difference for the routing decisions. But the problem with IRR database is that it is just what you put it in, right? And I can create my own IRR database and fill it with whatever I want. But of course, there are 5 regional internet registries. Their databases are very accurate. But if I look at the global IRR databases, there are a lot of them, like 25 of them, and RADB is a mirror of all of them. So there's a lot of garbage or unverified data in those databases. And if I'm making a decision on the basis of those databases, then most likely I'm going to make a mistake. That's why we are moving into a much more reliable system, which is called RPKI, which is Resource Public Key Infrastructure. It is just like IRR, but it gives you an additional option. But of course, it is the source of authentication is coming from the RIRs. As I said, they are the ones who allocated those prefixes to the customers, so they can verify who is the rightful owner of these prefixes. So the accuracy is there. The data is, of course, the accurate data is there, and then you can verify this data because it is digitally signed. So there are two options. So there are two things in RPKI. One is called the route origin authorization. What it says that in just like the route object, you saw a route and ASN. It binds this information together and digitally sign it, so that you can verify it just like you do it in a HTTPS website. You can verify that this is the right website you are logging into by looking at the certificate and who issued it and who was the rightful owner of this website. So you can verify this information. Similarly, you can verify the ROA, that who created it and when they created it, and this information is available publicly. So IP address and ASN to public keys. It binds the IP address and ASN to public keys. ASN X authorized to announce my prefix Y. I can create ROAs for anybody else. If I am the owner of the prefix, I can ask somebody else to announce it, and I can create a ROA for their AS number as well. So it's not like it is for myself. If I want to give it my ASN, my prefix to somebody else, or if somebody else wants to announce their prefix from my ASN, they can create a ROA, and it will be globally verified. I mean, there are many service providers who have created ROAs for all their prefixes, and that can be verified easily. It's right. So that's now the second phase of RPKI is called route origin validation. Number one was creating a ROA. It means you are creating a digital certificate or digitally verifiable information that this route belongs to this AS number, right? Or this route is authorized. This ASN is authorized to advertise this route. So that was the certificate or the ROA, route origin authorization. Once that is done, then you move to the validation part, right? If the world has created ROAs for all the routes they have, they are announcing, it is easier for me to validate that I will only accept if the ROA is valid. Anything invalid, if somebody is announcing a route which they are not allowed to as per ROA, then it will tell me, because I'm doing a validation, it will tell me that it has an invalid ROA attached to it, and that's why I'm not going to accept it. I mean, Telia Carrier is one of the ISP who is doing a route origin validation, so they're not going to accept if you try to announce somebody else's prefix without a valid ROA. There are many examples: NTT, Hurricane Electric, Telstra. There are major players who are doing route origin validation. If you have an invalid ROA, they will not accept it. But for that to happen, the world has to move into the a ROA. I mean, they have to create ROAs. Right now, we don't have more than 30% signed resources in the global routing table. Everything else is unknown. It means they haven't created ROAs for that. But still, the graph is going pretty rapidly, so people are signing ROAs for their resources. So this is how it works. Route origin validation is simply looking at the routes you're receiving and making the decision on those basis. And how does that work is it's a three-level model. You look at the prefix, you look at the origin ASN, and you look at the maximum length. So it can be, if somebody is trying to hijack a specific, like /24, you have only ROA for /22, and somebody is trying to hijack a /24, they will not be able to do it, because the ROA will tell it, validation will tell you that it's an invalid route because there is no specific /22 /24 ROA for that announcement. So all RIRs, they are the trust anchors, because of course they are the ones who have allocated these prefixes. They are the trust anchor. They can give you the right information. So there is a software called relying party software, or the RPKI validators. You install it, and then you connect with all trust anchors, which is hosted by all these RIRs. You get this certified information from them, and only forward a simple yes/no information to your router. So BGP is not making those cryptographic decisions. It is only making it is the relying party software who's making those decisions, rather the router itself. Router only gets the information that what is valid and what is not valid and what is unknown, and then make a decision on that basis. So it's very light on the router. It doesn't impact your BGP protocol itself, so it's easy to run. So if you are a network operators, please look into the route origin validation as well. Right. Going on, if you can verify this information as well, go to rpki.cloudflare.com/API GraphQL, and then you can put any ASN prefix in that query and look it up if it is valid or not. Whatever I have explained, this is the whole idea about MANRS. What MANRS is, we recommend implementing these 4 actions. All the actions I explained: filtering, anti-spoofing, coordination, making sure that you have the right information available on the internet, and global validation. These are the things we recommend as part of the MANRS initiative. And you heard from my colleague Kevin Maynell in the last session in detail, so I'm not going to give you a lot of information about that, but these are the 4 basic steps you have to take to be part of the initiative. There are many big names who are already part of this: Telstra, Telia, Carrier, NTT, and many more. But it doesn't make any difference if you're a smaller or a larger network, you can be part of it. There are different programs for different categories, for service providers, for IXPs, for CDN and cloud program as well. So it's simple. Why you should join? I mean, as I said, there are 71,000 networks in the global routing table. If we want to secure the global routing table, we have to make sure that more and more service providers are part of this initiative or doing the right thing. Even if you don't want to join the MANRS initiative, it's fine. At least implement those actions. And once you implement this action, well, you can just apply to be part of this community. So this is all from my end. If you want to read more, that how you actually implement these actions on your router, we do have an implementation guide. The initiative is technology agnostic. It doesn't matter which router vendor you are using. You can be using Cisco, Juniper, Arista, FRR, or Quagga, or Bird, or anything. But the functionality remains the same. These are all standard functions available in every routing OS, so you can implement it without any problem. So you go there and you can read the implementation guide. If you want to read more, learn more, then you can go to the training modules. They are available, again, free of cost, through our partners, and we will be launching our own updated version on ISOC Internet Society website as well. So please have a look. And on the last side, I would say that we will be doing a lab. So let me quickly share my screen. I hope you can see this screen. So just remember this link. It is called manrs.org-oc.org. And once you come here, you have to create your account, and then you can actually log in and then start a new lab. Once you start a new lab, you will see the exact lab which we were discussing in the presentation, and you can actually test all the actions we discussed in this slide deck. So you can do route filtering, you can do anti-spoofing, and of course, you can check if you are doing it correctly or not. It will tell you by itself if you have enabled the filters correctly or not. So I would request you to, if you want to try, you can try. Of course, there is a limitation of 25 people at one given time. So if you are interested in the lab, please reach out to Paulina, and she will help you creating an account. So that's all from my end at this point. If you have any questions or concern, please go ahead.
Thank you so much, Aftab. So yeah, I am Paulina for everyone in the audience. We will now take some time to answer some of your questions that have come in throughout the session. I first of all want to say thank you, Aftab, for a great presentation. I know me and several people in the audience have expressed that this was really, really great and insightful. So thank you. People have also asked if the presentation will be shared, and there will be a version of this presentation up on the Telia Carrier website shortly. So you will all receive an email with the recording once everything is available to watch. So that's coming. We've also gotten in a question, Aftab, about, so obviously this entire session has been about, you know, the problems of routing security and what you can do to secure a router and kind of, you know, do your part to make internet a safer place, and the MANRS initiative and so on. But, you know, despite all of that, as you mentioned in the beginning, we have attacks and hijacks happening every day. So I just want to hear your thoughts on how come not everyone, you know, chooses to implement these actions and so on.
Yeah, I mean, it's a very common question, and the problem is, number one is the understanding of the problem. The people don't realize, the service operators, the network operators do not realize that their inaction is causing such a big problem, right? They say, well, yeah, I'm such a small player, I'm not impacting the global router table, and the incident happens, and then all of a sudden they become they are in the limelight. So and again, as I say, if you go and search YouTube hijack right now, you will see the hits coming in from 2008 when PTCL did the YouTube hijack. It's a lot of, I mean, it's very long time ago, right? And it's still there. Every time people have done research, they still cite this information that it happened in 2008. If you are a network operator, you don't want to be part of that information, right? You don't want to be part of that history that you were part of a hijack. So it's easy in a way from a technical point of view. It's, if you're a large network like Telia Carrier, then of course it's a difficult, it's a long journey. It's at times difficult one, because you have a big network and many devices, so you have to take some major decision. But you have to start from somewhere, right? So Telia did it anyway, but so of course they must have started a long time ago. I know about the journey of Telstra. It took them like 6 months to implement all these measures, but of course eventually they did it. So if you are a small or a reasonable sized network operator, I think you should start making those decisions right now, so that you will be able to implement it in a couple of weeks or months. The biggest issue is not the technology. The biggest issue is actually the business decision. Because at times people say that, okay, what is the ROI of all these resources I'm allocating to implement these actions? Well, there is no ROI. The ROI is that you are securing the global routing table and you're securing your reputation. You are making sure that you are the good Samaritan, that you are not announcing anything bad to the global routing table, and you're not accepting anything bad as well. And you are making sure that the propagation stops at your doorstep. So that is the most important thing. If people start realizing it, the network operators start realizing that it will be easier for the engineers to make that happen. The technology is not the difficult part, I would say. I think it's the decision making is the difficult part.
Thank you so much. And then the last question for the day from the audience is how they can get access to the online lab and how they can create an account, basically.
So if they can just send an email to you, or they send an email to me with their, of course, with their email address, then we can give them access to the lab. They can, once they enable the lab, that lab is available for the whole week. They can try and attempt it whenever they have the time. So just reach out to us. Either you can reach out to us at to my email address, which is available on the slide deck, or you can send an email request to manners@isoc.org, or you can reach out to Paulina for that as well.
Perfect, definitely. Thank you so much, Aftab. That was everything for today. I want to say thank you both to you for this great presentation. We really appreciate your time and Kevin's time last week, of course, and really happy to collaborate on this with ISOC and MANRS. I also want to take a second to say thank you to everyone who tuned in today. And the recording and the presentation of this webinar will be available shortly. So thank you, everyone. Have a good rest of your day and evening for you, Aftab in Sydney.
Thank you so much for your time, and I really appreciate the effort from Telia Carrier for providing this platform. Hopefully, we can do it again. Thank you so much.
For sure. Thank you, everyone. Bye.